All right, lesson 7.7, unit 3. We're supposed to find two angles that have the following trigonometric values. So on the first one, the sine of 4/5, if you type that in your calculator, out will come, pen working here, 0.9273. The sine is positive in quadrant 1 and in quadrant 2. So you want to do pi minus that value we just got right there. So pi minus 0.9273 will be 2.2143. So you're doing pi minus this value right here to produce 2.2143. Okay, same approach on the next one. If you input inverse sine of 2/7 in your calculator, you'll get 0.2898. Do pi minus that, and you will get 2.8518. Keep in mind here is that the sine is positive in quadrants 1 and 2. Any given angle here, its supplement, pi minus that, will have the same value. So this rotation from here to here and from here to here, those are supplementary, and they'll have the same value, so that's why it's pi minus. All right, on the next one, if you enter it into your calculator, you'll get 3.2418. Now this one's a little bit tricky because the sine is negative down here in quadrants 3 and 4, and the angle, when you rotate all the way around into this quadrant, notice it's this angle is equal to its reference angle. So what I suggest that people do here is to get the reference angle by inverse signing 1/10 and then do 2 pi minus that, because to get down here to quadrant number 4 rather, down here, you want basically get all the way around into here. You want 2 pi minus the reference angle. So inverse sine 1/10, that's the reference angle. Then do 2 pi minus that, and you should get 6.1830. So inverse sine 1/10, that's the reference angle. Once you get that result, do 2 pi minus that result, and you get the second value. So same thing on the next one. You input it into your calculator, you're going to get 4.3321. Do the inverse sine of 13/14, which will give you the reference angle, and then do 2 pi minus that value, and you will get the quadrant 4, which is 5.0926. All right, now the cosine is positive in quadrants 1 and 4. So when you input the cosine, inverse cosine of 11/12, you're going to get 0.4111 approximately. And if you do 2 pi minus that value, you will get 5.8720 approximately 20. So the angle here, theta, and if you rotate that angle over the x-axis, you get theta here, or negative theta. The rotation all the way over to here is 2 pi minus the reference angle. So on number 6, same approach. We'll inverse cosine 1/9, we'll get 1.4595, and then we'll do 2 pi minus 1.4595 to get the quadrant 4 equivalent 4.8237. All right, on 7 and 8, the cosine value is negative in quadrants 2 and 3. So when you inverse cosine negative 7/8, you're going to get the quadrant 2 value, 2.6362. So that's going to give you this angle. Again, I would get the reference angle, the inverse cosine of 7/8, get that value right there, the reference angle. And then when you get the reference angle over here, the angle in quadrant number 3 is pi plus that value. And if you do that, you're going to get 3.6469 approximately. So same thing here, inverse cosine negative 2/5. You get the quadrant 2 value, 1.9823. inverse cosine positive 2/5 to get the reference angle and add pi, and you will get the quadrant 3 value, 4.3009. Okay, so that's that approach. Now, on the next section, we're going to work with the sum and difference formulas for cosine and sine. So first we have to figure out a sum of two angles that will give us these values. So on 75, I would use 30 plus 45 degrees. On 255, I would use 210 plus 45 degrees. Now, when you get to radians, it can be a little trickier. Some people will convert this to degrees, find a degree match, and go back to radians. So it's a little bit trickier here, but pi over 3 minus pi over 4 will do it, because pi over 3 is 4 pi over 12, and pi over 4 is 3 pi over 12. You subtract them, you get pi over 12. So that's pi over 3. Let me just make that a little clearer. Pi over 3 minus pi over 4. Negative 13 pi over 12 is negative 5 pi over 6 minus pi over 4. Justification here is that negative 5 pi over 6 is negative 10 pi over 12. And pi over 4 is what? 3 pi over 12. And negative 10 pi over 12 minus 3 pi over 12 is negative 13 pi over 12. So my suggestion here would be to notice that your denominator is 12. Create two fractions that have denominators of 12 with the pi's, and then try to figure out from amongst the angles you know what could subtract that negative 13. All right, so using these going forward, this is a fair amount of work with these. So on number 13, we're going to say that that's the sine of 45 plus 30. Now, you might do 30 plus 45, so it doesn't matter if you do 30 plus 45 or 45 plus 30. And so we're going to have the formula is the sine of 45, which is the square root of 2 over 2, times the cosine of 30, which is root 3 over 2. You can reference the formulas up there, plus the sine of 30, which is 1/2, times the cosine of 45, which is root 2 over 2. You do the math here, you get root 6 plus root 2 over 4. On 255, we decided that was going to be the sine of 210 plus, what did we say, 45. Okay, so what's the sine of 210? That's negative 1/2. And the cosine of 45 is root 2 over 2, plus the sine of 45, which is root 2 over 2, times the cosine of 210, which is negative root 3 over 2. And that's going to give you negative root 2 minus root 6 over 4. Okay, and the cosine of pi over 12, we said that we're going to do that one as the cosine of pi over 3 minus pi over 4. A little bit different formula here. So it's going to be cosine of pi over 3, which is root 3 over 2, times the cosine of pi over 4, which is root 2 over 2, and then plus the sine of pi over 3, which is 1/2, times the sine of pi over 4, which is root 2 over 2, giving us root 6 plus root 2 over 4. Okay, on the last one, we decided that it was going to be the sine of negative 5 pi over 6 minus pi over 4. So that's going to be the sine of negative 5 pi over 6, which is negative 1/2, times the cosine of pi over 4, which is root 2 over 2, minus the sine of pi over 4, which is root 2 over 2, times the cosine of negative 5 pi over 6, which is negative root 3 over 2. And then we'll end up with root 6 plus root 2 over 4. Luckily, you don't have to commit these things to memory. Okay, on 17 and 18, I think the first thing I would do is draw a picture here of what quadrant we're in. It says we're in quadrant number 2. And in quadrant number 2, that's the negative positive quadrant, right? So keep that in mind. Your cosine should be negative. Your sine should be positive. Now, knowing Pythagorean triples is extremely helpful here. So when I take the sine of u, and I say that it's 5/13. We're in quadrant number 2. The cosine of u is going to be negative 12/13. The Pythagorean triple here is 5, 12, 13. So the hypotenuse is 13 if one leg is 5, or if the radius is 13 and one leg is 5, the other leg is going to be 12. And since we're in quadrant number 2, the cosine is negative. And then on the second value, I'm going to put this over here just so we have the cosines together. It says the cosine of v is negative 3/5. And we're in quadrant number 2, so the sine of v should be positive. Pythagorean triple here is 3, 4, 5. So this would be, we're in quadrant number 2, so the sine should be positive 4/5. All right, so then now we're going to just plug our values in, right? So it's going to be the sine of u plus v is going to be the sine of u, which is up there in that chart was 5/13, times the cosine of v, which is negative 3/5, plus the sine of v, which is 4/5. Let's calculate that one, times the cosine of u, which is negative 12/13, I believe. All right, so if we do the math there, we get negative 15/65 plus negative 48/65, which is negative 63/65. Pardon my writing there. I'll fix that up for you. Negative 63/65. All right. Now, on the next one, we're using the same values. The cosine, this is going to be the cosine of u, negative 12/13, times the cosine of v, which we said was negative 3/5, minus the sine of u, which we said was 5/13, times the sine of v, which is 4/5. So we have 36 minus 20, which is 16/65. All right, so taking the same approach on this one, we're in quadrant number 3 now, so both sine and cosine are negative. So on the sine of u, we're given negative 7/25. So the cosine of u, the Pythagorean triple here is 7, 24, 25. This would be negative 24/25. Strongly suggest you make note of Pythagorean triples like 3, 4, 5, 5, 12, 13, 7, 24, 25, 9, 40, 41. So in the second one, I'll put cosine over here. Cosine of v is negative 4/5. So as we saw before, prior to problem, if you have 4/5, this is going to have to be 3/5 for sine of v. So that's going to be negative 3/5 because we're in quadrant number 3. So in this one, the sine of u is negative 7/25. Cosine of v is negative 4/5 minus the sine of v, which is negative 3/5, times the cosine of u, which is 24/25. That gives you 28 minus 72, which is negative 44/125. And on the last one in this section, it's the cosine of u, negative 24/25, based on over here, the chart we created. The cosine of v, which is negative 4/5, plus the sine of u, negative 7/25, times the sine of v, which is negative 3/5. This is going to give us 496 plus 21. This is 7 right here. And that'll give us an answer of 117/125. All right. All right. Now the last section here is not too hard because the basic formula, if you have a circle and you want to know the arc length of the arc subtended by the central angle here, and this is theta, and this is r. This is s equals r theta. It's important when you use this formula that the angle be measured in radians. So on the first one, if I flip my notes over, r theta is going to be what? R10 times theta pi over 4. Do your fractions there, you get 10 pi over 4, or 5 pi over 2, I guess. And if you evaluate it to 2 decimal places, it's 7.85. And don't forget your label inches. Excuse me. On number 22, R is 4. Theta is 5 pi over 6. That's 20 pi over 6, better known as 10 pi over 3. Into the calculator to 2 decimal places, 10.47. And these are centimeters. 23, radius 72 feet times central angle pi over 8. 8 down here. I'll cross cancel there, get 9 pi. Into the calculator, out comes 28.27, looks like feet. And last but not least, number 24, R 50 times theta, 8 pi over 5. Cancel 5 into 50, you get 10. 80 pi. In your calculator, approximately 25.33 yards. And there you go. So the formula S equals R theta. One last thing before I leave here. These formulas, my memory aid for these is that if it's a sign sum or a sign difference, notice that the binomial, the sign here agrees, the sign being SIGN, if it's sign of U plus V, in the formula to the right it's a plus, and the same thing with minus. But on cosine, if it's a plus here, it's a minus. So the cosine and sine kind of work in opposite fashions here. And then in the actual binomials within the formulas, the sign sort of integrates the two functions together. You get sine, cosine, sine. Whereas in the cosine formulas, it doubles up cosine, sine, sine. So you may want to think about that from a memory aid standpoint. All right, so that's the end of this particular